try relating the numbers on the left side of this table of values to the right side of the table of values with a linear function. So, any linear function can be written in terms of y equals mx plus b, where the term value is y and the term number is x. This is really useful when you're making a graph and you're using the term number on your x-axis and the term value on your y-axis. So let's make this for later. We may use it. Okay, so m, and when you write y equals mx plus b, represents the slope of the function, or the change in the y value. Actually, I'll just write delta. Delta, this symbol means change in, by the way. So change in y over change in x. Oops, change in x. So, for example, what would the change in y be if we go from this value to this value? So the change in y, you're looking at the right side of this table of values, would be, well, y2 minus y1, right? So, by the way, change in y over change in x is just equal to y2 minus y1 over x2 minus x1, right? Because y2 minus y1 would be a change in y, and x2 minus x1 would be a change in x. So if you take this as your first kind of relation and you take this as your second, then y2 would be 71. So let's say m equals 71 minus 75 over change in x. Well, x2 is 1, so 1 minus, and x1 is 0. 0. And so this is 71 minus 75 is negative 4 over 1, or just negative 4. And that's your m value. So, for your y equals mx plus b, you can write y equals negative 4, because that's your m. So negative 4x plus b. Now what does b represent? B represents the y-intercept. So the value of the function when x equals to 0. Now in this case, you're actually given it in your table of values 0. When you have x equals to 0, y equals to 75. So yeah, this one's a pretty simple one. Negative 4x, and then your b value would be 75, the y-intercept. But let's have another example in which you're not given the y-intercept. So let's say you have another table of values. This, by the way, was your answer for the table of values up there. Let's say you have another set of numbers. So let's say your x values are 1, 2, 3. Your y values are 9, 12, 15. And let's draw some lines. Make this nice. Okay. There. So you have this table of values. How could you find b in this case? Well, we would do the exact same thing. So y equals mx plus b. Find your m value, right? That's just your change in y over your change in x. So your change in y here would be 3, right? You went up by 3. You're going up by 3 each time. So 3. Over your change in x, you're going up by 1 each time. So this would be your m value. 3 over 1, which is just 3. So y equals 3x plus b, because 3 is your m value. Now how could we find b? How could we find b, which is the value at x equals to 0, when you don't know what it is on your table of values? Well, actually, you can just plug in x equals to 0 here, and no. You can just plug in any point, y value and x value, that you have in your table of values, and then you'll just have one equation and one variable, right? B. So you would get, let's plug in, I don't know, whatever point works, right? Third point, why not? So y value for the third one is 15 equals 3 times the x value is 3 plus b. So 15 equals 3 times 3, which is 9, plus b. Subtract 9 from both sides. 15 minus 9 equals b. And b equals 6. So your relation is y equals 3x plus 6. And that's how you would do it if you're not given in your table of values what your function at x equals 0 is. Alright, Hope you learned something. Good luck on your tests.